And Sammy, just so you know, I am recording this, so I'll go ahead and post that up later. I just go ahead and start the recording. So again, positive side, negative side. Now, if I change this and I wanted to do both of those at the same time, and I changed the interval from -10 10 to -10 of that same function, that would be 0. Because this is what they're talking about, or this side and this side. The graph is symmetrical, so that would be 0. So to do this online, all you'd have to do is go through and graph the particular function. And you can use any graphing utility to do that. And then just sketch the graph. Okay, so this one's actually interesting. If I give you the integral of the absolute value from 5 to 0 of 2x minus 5, and this is why we absolute values are so difficult to deal with. Going back on what we had before, the actual best thing for you to do first is graph this. Because right now you don't have a way to go ahead and do this particular piece. So if I graph this, where is the vertex of that going to be? The vertex of any absolute value symbol is always going to happen whenever the absolute value is equal to 0. That's the lowest possible point you can go ahead and get. So if I go through and solve this for x, I get 2x is equal to 5, or x is equal to 5 over 2. So in order to graph this, let's go ahead and just turn that into 2.5 right now. And let me make my scale a little bit bigger. Now I changed my mind. So now I have a graph that looks like this, correct? All right, so the area that I'm looking for is this. I want everything from 0 to 5. So the area I want is all of this. Going the other direction is going to just be taking that same thing that we had in the absolute value sign. We're going to go ahead and take that 2x minus 5, and we're going to multiply that through by a -1. And that will give us -2x plus 5. So that gives me this piece over here. So now I have it broken up into 2 different pieces. So now I can go through and find that area for both of them, and I just separate it. So now I go ahead and say, all right, that's going to be the integral from 5.5, because that was my split point, to 0 of -2x plus 5 dx. And then I have to add that from 5 to 5.5 of 2x minus 5 dx. And then you can go through and take the integral of that and plug in the two different values. Are you going to get the same answer? Is this graph perfectly symmetrical from 0 to 2.5 and 2.5 to 5? Yes, it is. So if you just did one of them, as long as the interval on both sides is the same, that you know the area from here to here and here on this side are the same, and that's only because you know the interval from B to A and B to A are the same. If the interval changed and the interval was from, say, 10 to 0, then that would not be the case. I'm only saying that because the interval between both of those are equivalent. Oops, I didn't record that. I'll start recording it now. So the lower sum is when you do the lowest piece that's inside the interval. So the lowest piece inside that interval is going to have me erasing this portion here. And a little bit more of that. So that's the lowest piece inside that first interval. So the lowest piece inside the second interval is up to here. The lowest piece inside that green interval gets all of this erased, and I go down to there. And then the lowest place of that yellow interval gets erased, and I get all of it erased because that would be 0. So my lower sum is just going to be 4 plus 4 plus 2 plus 0. And again, I'm getting those points by whatever the lowest point of that piece is, whatever the y value is I want to find the size of each of the rectangles. So that's the step one, is the size of each of the rectangles. How do I do that? Yep, b minus a. Okay, and then let me go ahead, take b minus a and divide it by n. So that's just 4 minus 2 over 6, or 2/6. Isn't that lovely? We have thirds. Okay, so let's go ahead and break this down. So I'm just going to leave these in fractions right now. So we're going to make that 2 and a third, 2 and 2/3, and then 3, 3 and a third, 3 and 2/3, and finally 4. Now I want a picture. It makes my life easier. So just go ahead and for f of 2, f of 2 is just 9 minus 2, which is 7. And then f of 4 is just 9 minus 4, which gives us 5. So f of 4 is here. F of 7 is up here. This is my line. Oops. No, it's not. Try that one more time. All right, that's as close as I'm going to get. So what I'm looking for is I have these 6 rectangles. So I want to find the area of this, the area inside here, the area of this, and my graph is absolutely not to scale. I do apologize with that. And I want to find all of these areas. And we are assuming all of these are shaded in where there's no spots. I apologize, my graph is definitely not as pretty as I would like it. There should be no gaps in between any of these. So it looks like that. Okay, so the width of each of these bottom pieces is 1/3. So I know down here that's that 1/3 for each of those pieces is that total distance. So now I need to find the height. So how do I find the height of each of these? I'm going to go back and look at the question, because are we using the right hand or left hand, or does it give us any directions? Use the left and right endpoints in the given interval for the number of rectangles between the graph and the f of x function. All right, so if I wanted to go ahead and do the left endpoints, what pieces do we have to have first? Yep, it's 1.3, or excuse me, 1/3 times f of 2, right? And then I have 1/3 times f of 2 and 1/3. Then 1/3 times f of 2 and 2/3 plus 1/3 times f of 3 plus 1/3 times f of 3 and 1/3 plus 1/3 times f of 3 and 2/3, and add all of it up. And if you do all of this out, and now I'm just looking at the book because I haven't plugged all of those in. However, if you look at that and you plug them all in, another way you can go through and just write 1/3 on the outside. And the first one was already 7, we have that one. And then it's going to be plus 20 over 3 plus 19 over 3 plus 6 plus 17 over 3, and then finally plus 16 over 3. And if you do that, you're going to get 12 and 1/3.